Section 1.2, Objective 3, Write equivalent fractions. Consider the fraction 3/4. I'm going to draw a picture that I already had drawn right here that represents 3/4. 3/4 means the same thing as 3 out of 4 parts. Now I'm going to take this picture that represents 3/4 and I'm going to represent it in a slightly different way. So here's 3/4. Everybody can see here that it still looks the same as my other picture, but now I'm going to make it look a little bit different. I'm going to cut it up into smaller pieces. It's still going to represent equally divided pieces, so each one of these pieces represents the same size. So now you can see that this, the original fraction 3/4 had 1, 2, 3. 3 out of 4 parts were shaded. And the second picture that we have here now has 1, 2, 3, 4, 5, 6 pieces out of 8 are shaded. So this is going to represent the fraction 6/8. I'm going to write that down. 6/8 means the same thing as 6 out of 8 parts. These two fractions, 3/4 and 6/8, represent equivalent fractions. They represent the same amount. Even though it looks like we have different numbers there, we're still talking about the same amount. 3/4 is equal to 6/8. So how do we go about obtaining equivalent fractions? Well, let's look at the 3/4 and let's talk about, well, how could we make that look like 6/8? Well, I would have to take the numerator. By the numerator, I mean the top number of the fraction. And I would need to multiply it by a number 2. And I would need to take the denominator. By the denominator, I mean the bottom part of the fraction. And I would also need to multiply that number by number 2. And if I multiply the numerator and denominator by number 2, I'm going to get 6/8. The reason I'm allowed to do this is because if you look at this fraction 2/2, 2 divided by 2 is equal to the number 1. And you're allowed to multiply anything by the number 1 without changing the value of the original number. So that's why we're allowed to multiply the numerator and the denominator by the same exact number. So generally speaking, if we were speaking about a general case, let's say we had this fraction a over b, which represents a parts out of b parts. I could multiply a times some number c and b times some number c, and that would produce an equivalent fraction, so long as c is not equal to 0. And also b should not be equal to 0 as well. So you can multiply the numerator and denominator by the same number c to obtain an equivalent fraction. Definition of the least common denominator. The least common denominator, which can also be represented by the 3 letters LCD, is the least common multiple of the denominators of a group of fractions. Finding the least common denominator is the exact same thing as finding the least common multiple, except that we are looking at the denominators of a group of fractions. Alright, so we're going to combine these two ideas into one. We're going to combine the idea of the LCM with the idea of equivalent fractions. Let's use this example. Write 5/8 and 9/20 as equivalent fractions with the least common denominator. The first step is to find the LCD. Finding the LCD means the same thing as finding the LCM of the denominators. So I'm just going to go ahead and write that in parentheses. We're going to find the LCM of the denominators. We already know how to do this step because we already learned how to do this and when we covered our section 1.2 objective 2 to find the least common multiple of 2 or more numbers. Let's factor out 8. I already know that the prime factorization of 8 is 2 times 2 times 2. The prime factorization of 40, first I'm going to factor into 4 times 5, and then 4 factors into 2 times 2. Now I'm going to take these two prime factorizations and I'm going to compare them. 8 is equal to 2 times 2 times 2. And then underneath it, I'm going to put the prime factorization of 20, which is 2 times 2 times 5. I'm going to vertically align any common factors that they have. I notice that they have 2 common factors of 2, so I'm going to circle those. Remember that that represents the GCF, 2 times 2, which is 4, but I don't want the GCF, I want the LCD. So in this case, I need to use all the remaining factors as well. A remaining factor of 2 and remaining factor of 5. So it looks like the LCD here, I'm going to have to multiply all these factors together. 2 times 2 is going to give me 4. 2 times 5 is going to give me a 10. And 4 times 10 is going to give me 40. So the LCD is going to be 40. That was our step 1. So step 2 is we're going to rewrite each fraction. I'm going to take 5/8. I'm going to multiply the numerator and denominator by the same number. Now what number should I multiply by? Well, I need the denominator to be a 40. So I look up here at the prime factorizations and I ask myself, what number was the prime factorization of 8 missing that the prime factorization of 40 had? It was missing a factor of 5. So I need to multiply by 5 to the numerator and denominator of 5/8. That's going to give me the fraction 25/40. Now for our next fraction is going to be the 9/20. I do the same thing. I ask myself, I look at the 20 and ask myself, what factor was the prime factorization of 20 missing that the prime factorization of 40 had? It was missing a factor of 2. So I'm going to take that extra factor of 2 there that was missing and multiply it to both the numerator and denominator of 9/20. That's going to give me the fraction 18/40. We're going to box that in. And that's it. That's how you do this problem.